Hello and welcome. My name is Mike and I'd like to show you how to join open vectors in V-Carve Desktop or V-Carve Pro. But before we show you that, I am going to show you some of the tools that are used. Here on the left side are the tools for joining vectors. If you right click on any one of your open vectors, or a vector for that matter, you get a menu. Go to selection, select all open vectors. It will highlight all the open vectors. Here we have a line, another line, and both are open vectors because they have open ends. The circle and the square, they're also shown as open vectors. I purposely made these two items, the square and the circle, an open vector for the purpose of this demonstration. Now, as you notice, all items, or vectors I should say, are highlighted. That tells me that that is a group of vectors. Now, join any one of these vectors cannot be accomplished because it is considered a group. I have to ungroup these vectors in order to be able to join any one of those vectors. In order to do so, we go over here to the left and we select that item or that tool, and it will ungroup the vectors. Now I can select any one of these four vectors and I could join. You can see that's a half a circle. It was deliberately made that way. This one, you can't really tell, but it is an open vector. If I take and go back to my selection tool, it will show that every one of them is still open vectors. 3 corners of this square is joined, one is not. We'll get back to the square a little later in this video. Right now I'm going to show you some of the tools used for joining vectors. We'll first start with these two angled lines. This tool here is joining two vectors with a straight line. For that purpose, we highlight the two lines, hold your shift key down, select the second line, select the tool, and you'll notice it drew a straight line from this end of this vector, from the end of this vector, straight across. Now I'll undo that by going up here to the menu and unjoin the vectors, and I'll show you the other two tools that are used for joining those two vectors. This is a straight line, this one draws a curve, and this joins two endpoints at common points. Let's do that one first. We'll select this vector, hold the shift key down, select this vector, select that tool. You see what it did? It moved the vectors to a common point. Now that may not suffice in most cases, because both vectors shifted their positions. Now I'll undo that once again, and we'll use the curve tool. Select one vector, hold the shift key down, select the other vector, and voila. The vectors did not change their position, they just drew a curved line running from the end of one vector to the other. Now we'll undo this, and I'll show you some other options that are available to you. If you right click on any vector, you get a menu. Now if I take and I right click on this one, shift click on this one, do a right click, I get another type of menu, and it's highlighted join closed vectors. We have the width of line, which is the same as this here. We have smooth curve, which is over same as this tool here, and you have move endpoints, which is the same as this tool here. So you have the option of using a right-click menu or the menu in the left corner. Either way, you can join your vectors. I'll join it with a line. I'll undo it. I'll go back here, highlight those two lines, join vectors, use the smooth curve. You see it works. We'll undo that. We'll select the vector with the shift key, right click, join vectors with move endpoints. So you can see there are various ways of being able to join vectors, whether you're used to a menu being shown all the time or a menu that's hidden that you can just right click on the vector and it brings it up in the menu. Okay, let's undo that, and we're going to move on to the circle. As you recall, the circle is two half circles making up a complete circumference. I did this on purpose. Both the square and the circle are open vectors. Here, if I go real tight, you'll see that it's open. But if you don't zoom in, it looks like a closed vector. Now, we'll go back to the circle. That's what we gotta close first, and then we'll move back to the square. I highlight one half of the circle, shift key down, left click, use this tool. It shows two open vectors, which is correct. You got the upper and lower halves. And that's beforehand, this is after. It shows one closed vector. In other words, it combined the two into one. Now, there you notice it changed. It is no longer two halves, it is a full circumference circle. Okay, now let's go and take a look at the square. The square, it looks very much like a square. Should be, but unfortunately it is not closed on all four corners. If I zoom in real tight on a corner, you'll notice this particular corner, there's a gap right there. That is the open vector in that square. The other three corners are tied together. But now you notice what I showed you here. There are instances where when you're looking at it natural, like this, it looks like a square, but it is not. You actually have to go in real tight on any of the corners to be able to find that open vector. But there's an easier way, and that's what I showed you earlier. You highlight your vectors, you right click, select open vectors, and it'll show you which vectors are open. It won't show you exactly which corners are open. Okay, now that we know what's open on that particular square, we need to close it. So we'll click on the surface here, then we'll highlight the square, and we'll use this tool to close that square to a closed vector. It shows it being one open, closed afterwards. We join it. It is now a closed square. Okay, now that we know what open vectors are in our project, we need to go and close the square because it is still open. We click on the surface, click on the square, and we'll use this tool right here to join those two nodes in this corner. And the reason I'm using this tool is because those two nodes are so close, this particular tool will join it with no problem. There you notice it is now a closed square vector. So now if we close this tool and we do a highlight of all our vectors, and we right click and check for open vectors, you'll notice the only open vectors in our project right now are these two lines. Now let's go back to the square, and I'll show you a couple other features that can join that square. First, we'll undo what the operation that was performed. Go check and make sure that it undid. Yeah, see, no corners are unmatched. Okay, now okay, now we know that the square is still open when we need to close it. Now let's go see what other options are available for closing that square. First, we're going to unhighlight everything, and we're going to go undo the join vectors, and we're going to check. Yep, it unjoined it. Okay, so now it's open. I'm going to go to the node edit mode for a moment, and I'm going to take and draw this, move this node way back. Now even there, you notice it looks like nearly a perfect square. Okay, let's tighten in a little further, and we'll drag it back some more where we actually have an opening that we can actually see. Well, we're beginning to see it. There we go. Now we move back. All right. Now we got an open vector square. Now, you can do a straight line and it'll join it. Let's undo that. You could have a condition such as what I'm about to show you here too. We go into node edit mode, and we're going to drag this out to just beyond that location. And you'll notice as I back out off of the zoom, it looks like a perfect square, which in reality it's not, and it's an open vector. And there's two reasons why it's an open vector. One, it doesn't cross, and two, you barely see it, but there's a gap between there and there. So what we'll do is we'll node edit, and we'll drag this one out also. Now we'll do a trim on that, making sure that this is checked off, because I'll join these afterwards. If you don't have this checked, it will not join those two corners. So we trim that, close that, zoom back out, do a check for our open vectors, and you'll notice now we only have the two lines that are open vectors. The square and the circle are now both closed. So you can see that there are several conditions that can exist that will look like a closed item, or closed vector I should say, but they are not actually closed. You must also remember that group vectors, when you group the vectors, as I did there, you cannot join the vectors. Even if you try to highlight it, it highlights as a whole group item. So in order to close those vectors, if they happen to be open, you have to ungroup those vectors. Now they're all individual vectors. These are considered closed. But to be truly sure that they're closed, do a right click, selection, select all open vectors. Yes, they are closed, and these two are open. Well, thank you, fellas, and enjoy. In this episode, we're going to explore hidden open vectors. I intentionally put some vectors in here that are hidden. Well, we're going to find them. Alright, we're going to highlight the vectors, select open vectors, and it's showing two here, and if you look real close, you could possibly see one there and one possibly there. But I have found that there's a tool. Well, here's one. I'll be darned. It's out of the range of the board, but it is a stray open vector. Okay, but what I have found is that this tool right here, if you highlight your vectors, it will tell you how many closed vectors and how many open vectors are in that drawing area that you defined. Here we have 2 closed vectors, 6 open vectors. So if I close this and I re-highlight this again and I do a right click, select open vectors, it really doesn't tell me how many vectors are open, but it shows me 1, 2, and you can also see that one. The other 2 are hidden within the framework of other vectors. Those are also considered overlaps that you will find when you use the Vector Validator tool. Now, to get rid of those open vectors, all we got to do is hit delete and they're gone. But of course now you also notice that these 2 vectors that I had drawn are gone too. We need to keep those vectors. So what I'm going to do is I'm going to undo my delete. I'm going to re-highlight all my vectors and I'm going to select open vectors. Now I'm going to take and hit the shift key and turn those 2 back on and then hit delete. Now I'm going to select all open vectors again and it shows me the only 2 available are these 2 here, which are actually open vectors because they're open on both ends, but the square and the circle are not. And you could also go back to this tool here, highlight everything in your framework. It'll tell you that you got 2 closed and 2 open vectors, which is correct. You got 2 open vectors, 2 closed vectors. So here we have shown you that you can also have hidden open vectors that are overlapped hidden underneath other closed vectors. So it is important that you make use of the various tools that Vectric has assigned to the software. I have found that this is a very useful tool right here. It lets you know exactly how many closed and how many open vectors are within the framework of whatever you've highlighted. Whether it be on the material board or outside that area. You can also have straight vectors way inside the zoom area that are real tiny that you can't find, can't see. So if you just highlight everything, select open vectors, it will show you all the unhighlighted, but when they're hidden behind other vectors, they're very hard to see. And if they're real tiny, they're also hard to see. So by making use of this tool right here, which is a join vectors tool, it will tell you exactly how many closed and open vectors are within that area that you highlighted. On this episode, we're going to talk about grouped hidden open vectors. You can have hidden vectors within a group. If I highlight this here, you'll see that it's a grouped vectors. Now, if I do a highlight of the whole area here, and I right-click, select open vectors, it'll only show these two. It won't show anything within that group. It'll show the two or any stray vectors you may have that are way back in the zoom area that's hard to see. Now, if I take and ungroup this, and I do the same thing as highlighting everything and right-clicking, select open vectors, it'll show me the open vectors within the group. You can see one here barely. There's one there, there's one there, there's one there, and if I zoom in real tight, there's one right here, a stray vector. Now also, if this is grouped, we'll regroup it, and we'll use this here, and we'll highlight everything. It'll show one closed vector, two open vectors, which is right, this and this. It's not going to show anything inside the group. It'll only show vectors when they're not grouped. Now if I turn this off and I ungroup this again, and then I go and highlight all my vectors once again, I go over here to this tool, join vectors. It now tells me there's 4 closed vectors, which would be 1, 2, 3, 4. And there's 7 open vectors. That would be 1, 2, 3, 4, 5, 6, and that real tiny one right there is 7. Now, if I hit the join, it's not going to do anything because there's really nothing to join. But now I know what my open vectors are, so I can highlight the grouped area, select only the open vectors, or all open vectors. Now there are some vectors I would like to keep. I want to keep this one, this one, this one, this one, and this one, but I want to get rid of that stray vector, so I hit delete. Now that stray vector is gone. Oh, also that vector that was there in the you can see how it darkened the line right there, but that's also another vector that's overlapped. And if I do a highlight of just that area, you'll see that it's turned magenta, and that means that's an open vector. So if I just hit delete, it's gone. Now you don't see an overlapped line. But that was one of the others that was in there. The stray vector and that one are the 2 that I wanted to get rid of. Now you can take these 2 vectors, which are part of the nose, and you can join those if you want. And it also, if I undo that and I re-highlight the nose, you'll show that it's showing no closed vectors, but there's 2 open vectors, which is this one and this one, and they will join afterwards once you hit the join button. This tells you what you will end up with after joining. But anyway, you can have group vectors, and the group vectors will not show any hidden open vectors within that group. You have to ungroup the vectors in order to use the Select Open Vectors tool to show all open vectors. Okay, let's talk about toolpathing hidden open vectors within a group. We're going to try to do a V-Carve on this face here. We're going to do a V-Carve toolpath. We're using a 60-degree bit. We don't need the clearance bit. We're going to go 100 thousandths deep on the F flat. We're going to call it V-Carve 1. We're going to hit calculate. Now you notice it says it's got 5 open vectors were identified in the selection and are being ignored. Some of or all of these vectors are in groups. Grouping open vectors do not join them. To use these vectors, you need to ungroup them and join them. There are 3 remaining vectors. This is a good pop-up window that shows and it tells you exactly what's going on. So we'll cancel that and we'll close the toolpath and we'll open up the face, ungroup it, and we'll find out what vectors are open vectors within that group. Alright, let's see, we do a highlight of the entire area. We select all open vectors. We know we want to keep these 2 vectors. Now it's showing the open vectors. It's got 1, 2, 3, and possibly a double one there, because if you notice the lines, it looks like it's doubled right there, and possibly right there too. But see, I can only call out a few that I can actually see. Now if I use this join vector tool over here, it'll tell me exactly how many open vectors are still open. We got 1, 2. See, is this joined? Yeah, it's a joined vector, so that's 1. And then the double line right there, let's highlight just that area. That's open vector there. And we'll highlight this area right there. That's an open vector there. So there was 5 open vectors total. That was including these 2 vectors up here, because I got 1, 2, 3, and then 4, 5 would be those 2. So what we'll do is we'll highlight. Well, I'll tell you what. Let's just highlight the face. It's throwing 3 closed and 5 open vectors. What it's doing is it's actually giving me all the vectors involved. Within that highlighted area. You've got the circle, which is a complete vector. You've got these other 2 circles, which are closed vectors. And then the rest are open vectors. You got the smile, which is doubled. That's 2. You got the nose. And then you got this one up here that's doubled. Now, we want to keep the closed vectors. So what I'm going to do is I'm going to hold down the Shift key and click on the ones that I want to keep. I want to keep the nose, and then I can hit delete and it'll get rid of the open vectors. Now I can re-highlight this. It'll show me there's 3 closed vectors, 2 open. Alright, the 2 open vectors is the nose and the smile. The 3 closed vectors are the 2 eyes and the actual shape of the face. So here in the toolpathing, we can go ahead and regroup this. We go back to our V-Carve toolpath. Everything is still here. We need to get rid of that right there. And we'll do a calculate. Now it's saying there's 2 open vectors, and that's correct because you do have the nose and the smile, which are 2 open vectors, and they will be ignored and you can pick that up on a profile toolpath, but they will not be carved with the V-Carve toolpath, as you notice here after it's reset. Now, in order to carve the nose and the smile, you would use a profile toolpath on the line. Profile, let's see, we would ungroup this, and then we would select the nose and the smile, and we got a profile toolpath, and we want a V-bit. So we'll grab a V-bit, 60 degree, and select, and we go on the line, and we calculate. Now we can preview all toolpaths, and of course I wasn't paying attention to the depths and all, but that shows you how you can create your toolpaths and with the open and close vectors. Anyhow, toolpathing can be a problem when open and closed vectors. You just have to know how to go about doing it.